Direct memory access, DMA. Now, before going to discuss DMA, now let us discuss about the data transfer between processor and IO devices, what we discussed in the earlier topics. Now, this is the processor and this is the memory which are connected to the system bus. This is the system bus, and IO devices are also connected to the system bus by using the interface circuit. Now, here I'll take input device, only input device I'm taking, and this is the interface circuit. Now, till now we have discussed the data transfer between processor to the IO device. Okay, now how it happens means by using the instructions like move data in comma R naught. Meaning is now in the interface circuit, already we have discussed inside register, address register is there, data register is there, status register is there, and control register is there. Now here the data register is nothing but when you are connecting the input device, we can say it as a data in register. If you are connecting the output device, we have to say data out register. Now every register is having its own address. That address here we have to mention. Meaning is what? Now from this register, we are moving the contents into the R0 register. R0 is nothing but what? Inside the processor, registers are there, control unit is there, and ALU is there. In that general purpose register, one of the general purpose register is R0. So we are moving the now in the interface from the data register to the register inside the processor, we are moving the data. Means our IO devices to the processor, we are moving the data. Now this is the instruction which we use to the transfer the data from IO input device to the processor. Now if this is one program, in this program, if this is the instruction, when this instruction occurs, then processor first fetches the instruction, after that decodes, and after decoding that, it will check the status register of the device. In this, if SIN bit is equal to, if the status bit, if SIN bit is equal to 1 means what? IO input device is ready. If this bit is equal to 0 means what? IO input device is not ready to send the data. Till that time, processor will wait. The processor, without doing any work, processor will wait till the IO input device is ready to send the data. So whenever the SIN bit is equal to 1, then processor reads the data by executing. Now if it is if the status bit is if status bit is ready, then it will execute and it will read the data from the data register to the processor. This is how what happens inside this. Now for this, so much of overhead is incurred. Now fetching, decoding, status register reading, and execution. So this mechanism is called as a polling mechanism. And to avoid this reading and to wait, and now when at the time of IO devices get ready, processor is not doing any work. So for to avoid that, now the second method is interrupt. So interrupt is nothing but when the device is ready, itself sends the interrupt signal to the processor. That till that time, processor can do some other job. Now, in this also, additional overhead associated like storing and restoring of the register content onto the stack. So when before it is going to execute the ISR, it will store the content onto the stack, and after completing that, again it will is restoring onto the registers. This is nothing but a extra additional overhead. So to avoid that, to transfer the block of data, bulk data with high speed, an alternate approach is used, that is nothing but when a special control unit may be provided to allow the transfer of block of data directly between external devices to the memory. So for that, now the control unit is called as a DMA, direct memory access. This is a control unit which is situated between IO devices and memory. Nothing but what already we have seen that interface unit, right? In the interface unit, we have a one control unit is there. So that part of the control unit is called as a DMA. Okay. Now what is DMA? DMA is nothing but is a special control unit, may be provided to transfer block of or block bulk data between IO devices and the main memory without continuous intervention by the processor. Now, once the data transfer is takes place, processor just initiates the DMA, and DMA will transfer the data between high speed devices to the memory or vice versa. That time processor will do some other jump. Now, how that happens, we will study with the DMA interfacing circuit. Now, what the processor do, whenever this data transfer is taking place, that time processor initiates the DMA program. Initiating DMA program is nothing but it will place the starting address on the address bus. Now here it will place the starting address. Now if this is a memory and this is the IO device, now where to start, now where to place the data, that starting address is placed into the DMA transfer. Now, if this is the DMA controller. In this controller, it will puts the starting address in this address register, and also it will put the count value on the word count register. How many number of words should be transferred, that is also placed onto the word count. And what is the direction, that is also given by the microprocessor. Now processor gives these three initiates the programs, means what, it will place the starting address, it will place the count value, and it will give the direction, means what, read or write. Now if this bit is equal to 1, then the read operation takes place, means what, from the memory to the IO device. If I'm taking IO device, from the memory to the IO, data transfer takes place. If it is if this bit is equal to 0, then write operation takes place, that is nothing but from the IO devices to the memory, data transfer takes place. Okay, read means what? Memory, IO devices reads the data from the memory. Write operation means what? IO devices sends or writes the data onto the memory. Now this is the inside what happens when the microprocessor initialize the DMA. Now after the initializing the DMA, now DMA itself, once that it knows the starting address, then after sending one word, next automatically it will increment the address, and again it will send the second word. Like that, till the counter value gets 0, it go on increments the starting address, that will be taken care of by the DMA. And after every word transfer, automatically counter value becomes decrement. Decrement takes place and it becomes 0. When the count value is equal to 0, then the done bit becomes 1. Now here the 0 bit becomes, 0 bit is nothing but a done. Done bit becomes 1. Job is done. Now within the status and control register, if the interrupt is enabled, once the operation is done, if done bit is equal to 1, then it will send the interrupt to the microprocessor by setting the IRQ bit is equal to 1. When the IRQ bit is equal to 1, then microprocessor receives the interrupt signal, thereby it will again takes the control of the bus. Now after initiating the program, microprocessor handovers the bus to the DMA. My microprocessor handovers the bus to the DMA. Now once the job is done, again it will send the interrupt signal to the microprocessor, then microprocessor takes the bus control. Now whenever I'm saying the processor is initiating or like that, means inside OS will take care of the IO transfer. Wherever the IO transfer is taking place, their operating system will do that job. Now if this is a program, now here the data transfer is, IO transfer is needed, then that time OS operating system suspend this program and it will initiate the DMA by initiating the DMA program, initiating the DMA program and handovering the bus to the DMA. And after completing the data transfer, DMA sends the interrupt signal to the microprocessor. With that, again, it will resumes the main program. After receiving the interrupt program, now it will take the control of the bus and resumes the main program. This is, wherever the processor I said, so how the processor is doing means because of the operating system inside. Now here you can see one diagram. here two DMAs are used. Now for this DMA, two disks are connected. Now this is a disk 1 and this is a disk 2. Now if disk 1 wanted to send the data to the main memory, that time now inside in this DMA, two channels are there. One channel is meant for the disk 1 and second channel is meant for the disk 2. Now if the disk 1 wanted to send the data to the main memory, then processor will write the starting address, number of words and direction in the channel 1. Thereby the disk 1 will send the data through the DMA, it will send the data to the main memory. Now here more than one DMAs are connected. Now here two types of data transfer takes place by using the DMA. One is a cycle stealing. Now here you can see one is cycle stealing and another one is block or burst mode. Now here the data will be transferred by using words. Now bits means already you know that 0 or 1 we can call it as a bit. Byte means byte is equal to 8 bits together we call it as a byte. Word means it is the length of the processor. Word is the length of the processor. Now 8085 is a 8-bit processor means what there. Now byte is a fixed length. Byte is equal to whichever the processor if you take. Now in any digital circuit, byte we will say it as a 8 bits. Coming to the word is the length of the processor. Sometimes the word may be 8-bit, sometimes it may be 16-bit. It depends on the processor size, the word will be decided. Now 8085 is a 8-bit processor, so there the word is 8. Now whatever the systems we are using, our laptops nowadays, it is a 64-bit microprocessor. Now in this case, in our system, word is 64 bits. So now here, whenever I say word means how many number of the length of the system is called the word. Now in a cycle stealing means what? Now here few words are transferred from the IO devices to the processor by stealing few memory access cycles from the processor. Now processor will originate so many most of the memory access cycles. Now in that DMA will steal few memory access cycles to transfer the data from the IO devices to the memory and vice versa. After transferring few words again, processor will gets the control of the memory, or you can say control of the bus. Now in the case of bulk or burst mode, now block of data, block is nothing but what? Group of words together is called as a block. Now here instead of sending the word by word, now here the data transfer takes block by block. Now it will send the data in a blocks, and in between without any intervention, if how many number of blocks should be transferred. So completed after transferring only the intervention takes place, or otherwise it will give the processor gets the control on the memory after transferring the data, block of data. So this is called the burst mode and this is called the cycle stealing. Cycle stealing mostly here it will transfer the data word by word. Now this will be useful for the slow devices. Now this is useful for the faster devices and high speed for bulk data. Now if only processor and one DMA is there, that time if processor and DMA both wanted to access the main memory by taking the control of the bus, that time DMA will get the access, bus access and memory access. So compared to the processor, DMA is having the highest priority. If both want the bus access or to access the main memory, then DMA will get the access. Now if two DMAs are there and if the two DMAs are wanted to access the main memory by taking the bus control, then which DMA will get the highest first priority, or which DMA gets the control on the bus to access the main memory, that will be decided by the bus arbitration process that we will study in the next lecture. So this is what the DMA operation.